Guys, welcome back to Maison African Motives, still on mathematics grade 10 revisions. We are going to focus on the question paper which was written November 2015, paper 1. That was actually 100 marks in 2 hours. So let us quickly rush through the questions so that we see what we were given here. So we're given on question number 1 to factorize the following expressions fully. That's 1.11. We have given x to the exponent of 4 minus 81. So as you know, guys, on your factorization, this is actually difference of two squares because the square root of x to the exponent of 4, that's x squared, or it can be written as x squared to the exponent of 2 minus the square root of 81, which is 9, which is same as 9 squared. So remember, on your difference of two squares, that one bracket is supposed to add the square roots, which is the x squared plus 9, and another one will subtract x squared minus 9. All right. So from this part, we can see that there is another difference of two squares, but these are perfect squares. We've got x squared, 9. So just like what we did from this one, we shall have two brackets, the square root of x squared, that is x, the square root of 9, which is 3. So one is going to add, another one is going to subtract. So that was actually 2 marks on 1.12. You're now given to factorize the expression of 6x squared y minus 10xy plus 15x minus 15. So whenever you're dealing with this type of factorization, this 1, 2, 3, 4 terms, so you group into 2, then you factor out what is common for the first 2 terms. All right, we have a common factor. We've got 6 and 10, which is 2. X here and x, we've got x, and also y is common. So 2xy was the highest common factor that we can factor out here. So if we divide 6 divided by 2, that is 3. X squared divided by x, that is x, y, and y will cancel. Minus 10 divided by 2, which is 5. Xy and xy will cancel. So you remain with 3x minus 5 in that bracket. So on the other terms that are remaining, we are supposed to factor out the highest common factor in this case, which is a plus 5. So if we divide 15x by 5, that is 3x, minus 15 by 5, that is minus 3. So you can see that we are having same brackets, 3x minus, that's 5. All right, so that's 5 here. And so you can factor out 3 so that it can be the same as this one. Or maybe I'm writing it wrong. Okay, that's 25, not 15 here. That's 25. So this is actually 25. So it is going to be a 5. So these brackets are the same, yes. So we're gonna have, we have to factor out the common brackets, these two brackets, which is the common bracket of 3x minus 5. If you factor out this bracket, you remain with 2xy plus 5 on the other side. So that is what you're going to have by factorizing fully. So let me just remove this part so that we can check the other part of the question, which is on 1.21, where we are given simplify the expressions. All right, so there we are supposed to actually factorize and simplify and add and subtract. All right, so let's just see if we are going to win if we write it here. So the first thing on the first part, there's nothing that we can do. Actually, just rewrite as it is 3 over a minus 4 plus 2 over a plus 3. Then we have got minus 21 over a squared minus a, which can be factorized. So we're going to have negative 21 over, since here the coefficient of a squared is 1, we can just have 2 brackets. Then we focus with negative 12. What are the factors of negative 12? But if you add them, they must give you the middle number, which is negative 1. So in this case, we have got a and a. All right, so the factors of negative 12 that we are going to have, let's try negative 4 and 3. All right, if we multiply this, it's negative 12. If we add, that's negative 1. So you're going to have negative 4 here and a plus 3. So remembering that we can find the LCM of everything, which is a minus 4. We've got a minus 4 here. A plus 3, we've got a plus 3 here. So this is going to be the lowest common multiple, which is the LCM or the LCD. All right, so remember that you're supposed to divide back the LCM divide by a minus 4. So a minus 4 and a minus 4 will cancel. That means you remain with a plus 3. All right, the same thing here, a plus 3 and a plus 3 will cancel. That means you remain with a minus 4. A minus 4, a plus 3, a minus 4, a plus 3, these will cancel. So you remain with just negative 21. All right, so you can expand brackets, then collect like terms. 3 times a, that is 3a. 3 times 3, that is 9. 2 times a, that is 2a. 2 times minus 4, that is minus 8. Then you've got negative 21. Do not expand the brackets, just leave them as they are in the denominator there. All right, so you can collect like terms. We've got 3a here and 2a. So that's 3 plus 2, which is 5a. Then on the numbers, we've got 9 minus 8 minus 21. So you can even use your calculator at once. That's 9 minus 8 minus 21, which is negative 20. So this is going to be a negative 20 here over a minus 4 into a plus 3. But if we are to check, there's something happening in the numerator there. We've got a 5, which is common. This is 5a minus 25. It's a factor of 20, so we can factor out 5. If we factor out 5, 5a divided by 5, that's a, minus 20 divided by 5, that's a minus 4. Okay, everything over a minus 4 into a plus 3. So there's something happening again here, which is the common bracket of a minus 4 and a minus 4. So these two can cancel. So therefore, our answer is going to be 5 over a plus 3. All right, so we had a lot of working. That was actually 4 marks. All right, so it deserves that 4 marks. Okay, so anyways, guys, we're supposed to work on match percents and revisions. So let's remove this and check the other part of the percent, which is on 1.22. So on 1.22, we are given again to simplify. So that's your exponents. So always try by all means to write these numbers in simplest form. So you check with the numbers that you have, which numbers can be in simplest form. So in this case, we have got 10, 25, and 4. So here we can actually write in terms of 25, this 10, it can be 2 times 5. Remember, 10 is 2 times 5. These are the prime factors of 10. But they are being raised to the exponent of 2x plus 3. So each number is going to be raised to the exponent of 2x plus 3. So this is going to be 2 to the exponent of 2x plus 3 by 5 also raised to the exponent of 2x plus 3. All right, we've got 4 here because of 2 that we have. So which means we are forced to write 4 in terms of 2. We know that 4 is same as 2 squared. But there is an exponent that we have, which is 1 minus x. So the 2 is going to be 2 into 1 minus x. So this 2 is going to affect everything. So it's going to be 2 to the exponent of 2 times 1, which is 2. 2 to the exponent, 2 times minus x here, that's minus x. All right, everything over 25. 25 can be written in terms of 5. We know that's 5 squared. But it's going to be affected again by the exponent, which is 2 plus x. So we are going to multiply, which is 5 to the exponent of 2 times 2. That is 4. 2 times x, which is 2x. So that's what you're going to have at the end. So from this part, guys, we can see that we have got 2 here. So they are multiplying actually the base of 2 and the base of 2. Remember that if you're multiplying, you add the exponents. So it's going to be 2 to the exponent of 2x. So that's 2 to the exponent of 2x plus 3 multiplied to 2 to the exponent of 2 minus. So you add. So it's going to be plus 2 minus x. All right. Then we've got 5 here raised to the exponent of 2x plus 3 and divided to the 5, which is raised to the exponent of 4. So if you are dividing, you subtract. So the moment you subtract, guys, make sure that you open a bracket because this is now an expression. So it's 4 plus 2x like this. All right, so what we're going to have at the end, guys, let's collect like terms and simplify where possible, wherever is possible. Let us try by all means to simplify everything. All right, guys, here 2 times 1, that's 2. 2 times minus x, that's minus 2x here. So we've got minus 2x here. Sorry for that. All right, so this is negative 2x. Sorry for that, guys. I'm seeing that does not add up. All right, anyways, if we are to collect the like terms, we've got 2x minus 2x, that's a 0 there. So we're going to add 2 plus 3, which is 5. So it's 2 to the exponent of 5 times 5. If we are to simplify, it's negative times 4, that's negative 4. Negative times positive 2x, which is negative 2x. So you can collect like terms. 2x minus 2x will cancel. We've got 3 minus 4. So 3 minus 4, that is a negative 1. All right. So we know that 2 to the exponent of 5, you can even use your calculator. 2 times 2, 5 times, that's 32. Times 5 to the exponent of negative 1, which is same as 1 over 5. Guys, I talked about this. X to the exponent of minus a is 1 over x. So that is the part. So you can multiply 32 times 1, which is 32 over 5. So that's what you're going to have. Or you can simplify further, but you can even leave your answer like that. All right, so that was question 1.22. On question 1.3, consider the following: the square root of 27, the cube root of negative 27, the square root of negative 27. Which one of these is, okay, irrational? So remember, I talked about the irrational numbers. If you are dealing with irrational numbers, these are numbers that they are not exact, okay? So they are not exact. When expressed as decimals, they do not end. So you can cross-check what we have on the square root of 27 there. It's an endless decimal. So this is actually an irrational number. The cube root of minus 27, that is negative 3. It ends. The square root of minus 27 cannot be simplified. This one, you can't even simplify it. Square root of minus 27. That's not a real number, actually. Yeah, does not exist. This one, you can't even simplify it. So you can see that the irrational number was the square root of 27. Then the non-real is the square root of minus 27. We can't simplify that one. We saw that it gave us error, which means we can't simplify that. So that was question number 1, having a total of 16 marks. So you're going to check question number 2. Solve for x. So the first part on question 2 is to solve for x, and we are given a quadratic equation on 2.11, which is given as 15x squared minus x is equivalent to 14. So as you know, quadratic equation is written in the form of ax squared plus bx plus c is equal to 0, which means one side must be equal to 0. So you transpose 14 to the other side. So it's going to be 15x squared minus 14x. Then already we've got a negative 8, which is on this side. All right, so we're supposed to solve for x. We can use our quadratic formula, or we can use factorization method. Okay, so trying on factorization method, this time the coefficient of x squared is not 1. So you are forced to multiply the first term to the last term. All right. Multiplying the first term to the last term, what we have, 15 by negative 8. Let's see. That's 15. 15. Okay, we need to remove everything. That's 15 by negative 8, which is something like negative 120. So all you need is to find the factors of negative 120 x squared. But if you add these factors, you must obtain a negative 14. All right. So that's the idea that you actually need in this case. Which are the factors? All right, so let's try between these numbers here, these numbers. There are so many numbers, guys, that we have. So it's actually a matter of trying. Okay, let's try between negative 20 and positive 6. All right, let's try these numbers. Negative 20 by 6, that's negative 120. Negative 20 plus 6, that's negative. So these are the two numbers that you're going to use. So you substitute or you replace these numbers into the middle term, which means in place of minus 14x. So it is going to be 15x squared. So you can even start with a positive 6 plus 6x, then minus 20x minus 8 is equal to 0. So as you can see, we've got 4 terms. So you're now back to grouping, whereby you have to group the first 2 terms. 3x is common. So you can factor out 3x. 15 divided by 3x, that's 5x. 6x divided by 3x, this will give us 6 divided by 3, which is 2. X and x will cancel. we can see here we've got -20 and -8. Negative is common, but which number? -4. So that this can be 5. So -20 divided by -4, that's a +5. We remain with x. -8 and -4, that's a +2, equal to 0 there. So since the two brackets are the same, what do? We factor out the common bracket of 5x plus 2. We remain with 3x. Here we remain with -4 in another bracket, equal to 0. So this is the normal stage that we are used to, where each bracket must be equated to 0. So 5x plus 2 must be equal to 0, or 3x minus 4 must be equal to 0. So you can solve for x, transpose 2 to this side, that's -2. We divide by 5 both sides, so x is going to be -2/5. The same thing if we transpose -4 to this side, it's going to be a +4. You divide by x both sides, so x is going to be 4/3. All right, so those were the two possible values of x that we could have found. We worked it properly. Let's check the other part of the question, that is 2.12, where we are given 5 to the exponent of x is equivalent to 1/25. 125. Okay. So these are actual indices. Okay, exponents. We know that if you're dealing with exponents, we're supposed to write in the same base. So 5 to the exponent of x is in simplest form. 1/125 can be written in terms of 5. That's 5 to the exponent of 3. So if you multiply 5 times 5 times 5, you get 125. So if you do not know this, you try all the exponents up to a number where you get 125. Okay, 1/5 to the exponent of 3 is the same as 5 to the exponent of -3. Remember, x to the exponent of -a, it's 1/x to the exponent of a. So you simply introduce a negative on the exponent. So that means 5 to the exponent of x is equal to 5 to the exponent of -3. If the bases are the same like this, it means the exponents are the same. So therefore, x is going to be equal to -3. All right, so that was the question. And if we are to check on question 2.2, we are now given the following is the following inequality is given as 3 into the bracket of x plus 7. So this is 3 into x plus 7 is less than x/2 plus 1. So the first question was to solve for x in this inequality, and that's 3 marks for that. All right, that's 3 marks, sorry. So for you to solve this inequality, there are so many ways. You can expand the brackets. You can divide by 3. I don't know which one was best for you. All right, but okay, let's do this stage by stage. Let's just expand the brackets by 3 here. So it's going to be 3 times x, that's 3x, plus 3 times 7, which is 21, is less than x/2 plus 1. As we can see, there is a fraction on x plus 2. So what can we do? We can choose to remove the fractions, or we can choose to just collect the terms together. There are so many ways. Okay, so I'm just going to work them both here. All right, so let's just write it aside so that I won't forget. 3x plus 21 is less than x/2 plus 1. So you can just neglect the fraction as it is, but this is the same as 1/2. You transpose 1/2 to this side. So it is going to be 3x minus 1/2x is less than, then we transpose the 21 to this side, is going to be 1 minus 21, of which 1 minus 21, okay, let's just write 1 minus 21, that's -20. So 3 minus a half, that's 3/2, is that so? 3 minus 1/2, yeah, that's 5/2. Okay, so it's going to be 5/2x is less than 1 minus 21, that's -20. So to find x, you simply divide by this number that is affecting x, which is 5/2, both sides by 5/2. So x is going to be less than -20 divided by 5/2. So we've got -20 divided by that answer that we got, that's -8. So x is less than -8. So you could have done it that way, or you can remove the fractions here by, because we've got this is over 1 over 1 over 1. So you simply, the LCM is 2. So you multiply each term by 2, here by 2, here by 2, here by 2, so that you remove the fractions. All right, so that's 3x times 2, which is 6x, plus 21 times 2, which is 42, is less than 2 and 2 cancel, you remain with x. All right, 1 times 2, that is 2. So you're going to collect like terms, just like what we did previously. The x to this side is going to be minus x. So 6x minus x, that's 5x is less than. We transpose the 42 to this side so that it is going to be a negative 42. So 2 minus 42, that is minus 40. So to find x, divide by 5 both sides. So x is going to be less than negative 8. So that's what we had on question 2.21. Then on 2.22, represent your answer on question 2.21 on a number line. Okay, we have been talking about the number line. Okay, let's just see. So a number line, the most important value that you're going to indicate on your number line are the values of x from 0, so that we can know where do we have minus 8. Is it on the right or on the left? So minus 8 is on the left side. So we are given that our x is less than negative 8. So you do not shade the circle at negative 8. You indicate values less than negative 8. So here we've got negative 9, negative 10. We have got negative 7. So you just test the values. Which one are less than negative 8? So you can see minus 9, minus 10. These values, they are less than negative 8. So your arrow is going to point that side to the values which are less than negative 8. If it was greater than 8, then your arrow points to the values which are greater than 8. All right, so that was 2.22. All right, so 2.22. So this is going to be 2.22. All right, on 2.3, we are given, let's remove so that we can just work it down here. So on 2.3, we are given that Mary gave 1/3 of her money to Nazim, and it's Nazim, okay. And 1/5 of her money to Eletu. Eletu received 28 rand less than Nazim. How much money did Mary have originally? All right. How much Mary have originally? All right. This is what you're going to do. The money that we have is given in terms of Mary. Okay, so this is Mary. So let's just say Mary's original share, original amount, not original share. Original amount was X. Okay, let it be equal to X, right? Okay. From this, we are given that she gave 1/3 to Nazim. Okay, so Nazim here got 1/3. Okay, so this one got 1/3 of X, which is 1/3X. That's 1/3. All right. Then 1/5 of her money to Eletu. So Eletu here received 1/5 of the amount. All right. So this is 1/5 and the other one is 1/3. So these two now, we are given that Eletu received 28 rand less than Nazim. Okay, this is where our equation is going to be formed from. This guy, Eletu here, she received 28 rand less than Eletu. So what does it mean? It means that if we are to remove 28 rand from this one, which is Nazim, we are going to obtain the amount that was received by Eletu. So we are going to equate the amount for Eletu here, which is 1/5, to the 1/3 of X. Then we subtract the 28 rand from that. So that's an equation that you have formulated. So you can clear fractions just like what we did, or you can just work with the fractions. It does not matter. 1/3 to this side is going to be minus. So it's 1/5X minus 1/3X is equal to negative 28. So 1/5 minus 1/3 from our calculator is going to give us what? 1/5 minus 1/3. All right, so that's negative 2/15. So we've got negative 2/15X, which is equal to negative 28. So to find X, you can just divide by negative 2/15, or you can cross multiply, then you divide by minus 2, depends. So just divide by negative 2/15 so that you remove this on X. So it's negative 28 divide by negative 2/15. Negative 28 divide by the answer that we got is going to be 210. So originally, our X is 210. So that means originally Mary here had 210 rand. That was the amount that she had originally. All right, so that was actually a word problem of playing around like those word problems that you see on WhatsApp. All right, anyways, they ask that type of question, so you have to answer it. Okay, so on question 3, we are given the linear number pattern. So that's a linear sequence that we are given. Write down the next 2 terms of the pattern or the sequence. So what you need is a linear pattern. So we know that if we are dealing with a linear pattern, there is always a common difference between the terms. So we are supposed to know the common difference between these terms. So this will be like, this will be T1, this will be T2, this will be T3, and so on. So actually the common difference we are subtracting, that's the D is equal to T2 minus T1, or it can be T3 minus T2, and so on. So you subtract here 3 minus 8, that's minus 5, okay? We move on, minus 2 minus 3, that's minus 5 again. So there is a difference of minus 5 throughout. So to find the next term, which is T4, you just have to add the term that we have, which is minus 2 plus the difference of minus 5. So minus 2 plus minus 5, that's minus 2 minus 5, which is minus 7. So we are going to have negative 7. We add again, because there are 2 terms, we add again a difference of minus 5. So it's negative 7 plus minus 5, which is negative 7 minus 5, that's minus 12. Okay, that's minus 12. Okay, so you can just use your calculator also to cross-check the values there. All right, so these are the values that you're going to have. On 3.12, determine the nth term of the pattern. So the nth term, remember, guys, I talked about this. So this is 3.12. Remember, I told you guys about the nth term, that it is given by the formula A plus n minus 1 times D. Just try by all means to memorize this formula, where A is the first term, number of terms, and the common difference. So that means Tn is equal to A. That's our first term here, which is 8. So we've got a first term of 8 plus n minus 1 times the common difference. We saw that there was a difference of minus 5. So you just multiply by negative 5. Actually, there are so many ways of doing this. I'll work them out with you so that we can be able to understand them on separate videos. So our Tn is going to be 8 plus here the negative. So it's plus and negative, that's a negative. So negative 5 times n, that's minus 5n. We move on, negative 5 times 1, negative 1, that's a positive 5. So Tn is going to be, we collect the like terms, 8 plus 5, which is actually 13. So we are going to remain with minus 5n plus 13. So this will be minus 5n plus 13. So take note, it's a linear expression whereby the common difference that we have of 2 can be given in so many ways. So I'll explain those methods in different videos. Okay, 3.13, calculate T30, the 30th term of the given expression or the given pattern. So that's T30 where n is equal to 30. So you're just going to continue from your Tn here, your n is 30. So T30 in place of n substitute 30. So that's minus 5 times 30 plus 18. So that's our T30 here. All right, so let's see. Negative 5 multiplied by 30, whatever that we get, we must add 13. So that will be negative 137. So that's our T30, negative 137. All right, on 3.4, we are now given which term of the pattern is equal to minus 492. So we are just equating our Tn to 142. So that was 3.14. So Tn is equivalent to negative 492. So what does it mean? It simply means that Tn that we have here must be equated to negative 142 so that you can calculate n. So negative 5n plus 13 is equal to negative 492. So negative 5n is equal to, if we transpose 13 to this side, it's going to be minus 13. So we are going to have minus 492 minus 13, which is negative 505. So that's negative 505. All right, so to find n, we can just divide by negative 5 both sides, by negative 5 both sides. So n is equal to what? Negative 505 divided by negative 5, that is 101. So we're talking about the 101 term. All right, so that was the value of n. On 3.2, we are now given the first four terms of pattern A and B are shown. Okay, so we are given the position of n, the first term, second term, third term. So these are the pattern. Determine the general formula for the nth term of pattern A. So we are given pattern A. What is the general formula that we can use on pattern A? Okay, so let's just remove this part so that we can use this space here. So this is 3.21. So what you simply need to check is the type of the pattern that you are given. If we are to check here, we have got 1, 3, 5. So there's a difference here. 3 minus 1, there's a difference of 2. 5 minus 3, there's a difference of 2. 7 minus 5, there's a difference of 2. So that means it's a linear expression. So here we are dealing with a linear expression where we know that Tn, which is the nth term, is given by A plus n minus 1 times D, that formula that we talked about previously, where A is the first term and our first term of the pattern, that's a 1. So it is going to be 1 plus n minus 1 times D, which is the common difference. There is a difference of 2 on these terms. So that's our Tn, which is 1 plus 2 times n, which is 2n. 2 times minus 1, that's minus 2. So Tn is equivalent to 2n. 1 minus 2, these are the like terms, which gives us a negative 1. So our Tn can be given as 2n minus 1. All right, so that was it for this one. Hence or otherwise, the general of the nth term of pattern B. All right, what is happening on pattern B, guys? Okay, this is what is happening. For the value of n that we get here, we have a 1. The first one, it gives us a 1, okay? This is 3, and this is 9. 5, this is 25. 7, this is what is happening, guys. We can see 1 was being squared. It was 1 squared. This was 3 squared. This was 5 squared. Whereby the 1, the 3, the 5, the 7 is the one that we said it's a linear expression or a linear pattern, which is the one that is given by 2n minus 1. So it means to find the Tn of that pattern, it is just going to be the value that we have, then we square it. So if that value that we have is 7, it's represented by the formula Tn minus 1, 2n minus 1. So simply, we are going to square that to n minus 1. So that's why they said hence. So you can have it like that, or you can, there's so many ways that you can do, guys. You can do so many ways. Okay, so that's what we had. Then hence, determine the general formula for the pattern 0, minus 6, minus 20, minus 4 to simplify your final, your answer as far as possible. As far as possible. All right, do we have any difference which is common here? Okay, we've got minus 6, you've got 14. We do not have a difference which is common. All right, so what is actually happening? These are negative values that we are obtaining. I want you to see what is happening here. I want you to cross-check because this person is very, very tricky, very, very tricky if you do not understand what is happening. So you analyze your person. So you can see that here, what was simply happening, the first term is a 0. The second term is a minus 6. So we can see that it was pattern A minus pattern B. 1 minus 1, that's a 0. 3 minus 9, that's minus 6. 5 minus 25, that's minus 20. 7 minus 49, that's minus 42. So this pattern that we see here, it was simply taken from Tn of pattern A minus Tn of pattern B. This is what is simply happening because we are subtracting A minus B. So to find the Tn, we are simply subtracting Tn of pattern A, which is this one of 2n squared. Or for pattern B, sorry, pattern A, it was 2n minus 1. So it's 2n minus 1 minus pattern B, which was 2n squared, 2n minus 1 squared. So this is what is represented by Tn, but these are like terms that they can be like terms if we are to expand the brackets. So we've got 2n minus 1 minus, remember your identities, 2n squared, that's 4n squared minus 2n times 2, which is 4n, 1 squared, which is 1. So we can expand the brackets. That means our Tn is going to be 2n minus 1 minus and 4n squared, that's minus 4n squared, minus and minus 4n, that's plus 4n, minus and 1, that is a plus 1. So you can collect like terms. We're going to have minus 4n squared, followed by 2n and 4n, 4 plus 2, that's 6n. Okay, we move on, minus 1 plus 1, that's a 0. Okay, that's minus 1 plus 1, and that one is actually giving us a 0. Okay, guys, negative 1 times, because it can't be a negative, it can't be a 0 here. Negative 1 times 1, that's minus 1 here. So this we're supposed to have minus 1. So it's minus 1, which is minus 2. So that's our Tn. So you can expand. Okay, on expanding this bracket, there are so many ways. We could have expanded these brackets by having two brackets of 2n minus 1, then you expand each to another. So many ways, guys, that we could have used there. So many ways. Okay, so that's what you're going to have in this case. Just have to work on match questions as much as you can. All right, so let's see the other part of the question. That's question 4, functions. All right, question 4. All right. Let's see. Let's try to remove some other things here. All right, so on question 4, we are given that f of x is given as a negative 2x squared, negative 2x squared plus 2, and g of x is 2 to the exponent of x plus 1. I'm just going to take these functions down here. So we are given f of x 2 to the x, that's minus 2x squared plus 2. All right, so we are given f of x, that's negative 2x squared plus 2, and we are also given gx, which is 2 to the exponent of x plus 1. All right, so that's 2 to the exponent of x plus 1. So the first part of the question, which is 4.1, is asking us, write down the equation for the asymptotes of g. Okay, this is our g. So you know the asymptotes is at 1. This is an exponential function. So the value that is being added to y there, that's the asymptote in terms of y. Then x, you equate this value of x to 0. So which means the asymptote is going to be at x is equal to 0 and y is equal to 1. So that's 4.1. So x is equal to 0, y is equal to 1. Okay, so actually at x is equal to 0, we do not have an opposite. It's going to be, it's not direct, that one. So this one is not going to be there. Sorry for that, because it is going to be the y-intercept for this one. So we just have one asymptote. So yes, take note for that. All right. Then on 4.2, sketch the graphs of f and g on the same set of axes, clearly showing all the intercepts with axes, turning points, and their asymptotes. All right, so that was the question. So what can we do, guys, to sketch these graphs? 4.2. So let's start with f of x. On f of x, we are going to need the x-intercept and the y-intercept. Okay, so for the x-intercept, we know that y is equal to 0. So let's start with the x-intercept, where we know that y is equal to 0. So if y is equal to 0, then we are going to have this 0 is equal to minus 2x squared plus 2. So you can solve this. 2x squared to this side, that's positive, minus to this side, that's positive. 2x squared is equal to 2. You can divide by 2, so x squared is equal to 1. So to find x, introduce the square root. This is squared, so you introduce the square root both sides. So x is going to be plus or minus 1. All right, so that's our x-intercept. Then we move on to the y-intercept, where we know that x is equal to 0. So if x is equal to 0 here, it means our y-intercept is at 2. All right, so y is equal to 2. So for this function, if it is given in this form, the 2 that we see at y is also the turning point. So we have the turning point at that 2 that we have. So this information is enough for us to sketch this graph, and also taking the coefficient of a squared, it's a negative. So it is going to be like this, okay, a sad shape. It's going to be a sad face, okay? If it is positive, it's going to have a smiley shape. All right, so that's what you're going to have here. We've got our 0, our x, and our y. So we saw that the x-intercept are at plus 1 and minus 1. So we can just say this is minus 1, minus 2, minus 3, minus 4, 1, 2, 3, 4. Minus 1, minus 2, minus 3, 1, 2, 3, 4, 5, 6, and so on. Okay, so the x-intercepts we have got -1 and 1. So that's -1 here, 1. The y-intercept is at 2. Y is equal to 2, and it's also the turning point. So your graph is going to be like this, passing at 2 there, then passing at 1 like this. All right, so this will be the graph of f. Okay, so that's our f of x. Then let's see about g. Okay, this is our gx. On gx, we say the asymptote is at y is equal to 1. So there's an asymptote, which means this graph is not going to pass through this line of y is equal to 1. So let's indicate the asymptote first. Y is equal to 1. That's like this. All right. So that's y is equal to 1 is an asymptote. So let's check the x and y intercept. Let's start with the x-intercept. All right, the x-intercept is at y is equal to 0. So if y is equal to 0 here, we've got 0 is equal to 2 to the exponent of x plus 1. So that means can we solve this equation? -1 is equal to 2 to the exponent of x. There's nothing that we can get. All right, guys, it's a waste of time. Remember, this graph cannot even cross y is equal to 1. So there's nothing at y is equal. There's nothing in the x-axis because remember your x-axis is y is equal. So there's nothing that you can get. So leave it like that. So let's work with the y-intercept. So there's nothing there. So the y-intercept is that x is equal to 0. So when x is equal to 0, we substitute here. That's a 0 on x. So it's going to be y is equal to 2 to the exponent of 0 plus 1, which is 1 plus 1. That's a 2. So y is going to pass at 0.2. So that's what you're going to have for the y-intercept. So it is going to pass through the same point that what we had at 2 here. But remember the shape, guys, it's a positive. So it's going to be like this, an exponential function. You're supposed to know the shape of the graph that you're drawing, guys. Okay, so know the shapes of the graphs that you're drawing. So it is going to pass through 2 and like this. So at 2, that's actually a contact. It's a contact between the two graphs. All right, so that was your graph for G, which is GX. All right, so we've got our graphs drawn. All right, so that was it. On 4.3, we are now given, that's 4.3. All right, write down the range of f. So the range of f, well, let's check our f here. That's our f. So as you can see, our f is limited at 0.2 here, which is the maximum turning point at this 0.2. So which means it is going to reach 2 and goes down. It can't go upwards. Okay, so that was 4.3. Okay, 4.3. So the range, we are going to refer to the values of y which are less than or equal to 2. The y is not going to exceed this one. All right, so or from -infinity up to 2. You can write it that way, from -infinity up to 2. All right, so that was the range. Determine the maximum value of hx. Okay, the maximum value of h, if hx is equivalent to 3 to the exponent of fx. Okay, so let's start by having a new hx. So this is question 4.4. Okay, so that's 4.4. So let's start by having the new function here, which represents hx. We are given that hx is equivalent to 3 to the exponent of f of x. That means hx is equivalent to 3 to the exponent of f of x here. Remember, our f of x is minus 2x squared plus 2. That's minus 2x squared plus 2. All right. So this is minus 2x squared plus 2, like this. Plus 2. All right. So the question is asking, where are we going to have the maximum value of x? What is the maximum value? All right, so what you need, guys, is that if you are dealing with a function, or which is an inverse function, the maximum value can be taken when we are having the value of x at which is equal to, because this one is a negative, so you're going to have it at x which is equal to 2. So at that moment, your x must be equal to 2 for it to be maximum. So therefore, the maximum value now can be taken if x is 2. So this will be 3 to the exponent of 2, which is at 9. So this is obtained where we are having the maximum value when our x is 2. Okay, so I think this is direct. Okay, maybe if you do not understand, guys, let me know. There can be so many ways of explaining these typical questions, but as you can see, it was actually 2 marks for that. Okay, what is the transformation? What does transformation? Okay, what transformation does the graph of f, y is equal to f of x, undergo in order to obtain y is equal to 2x squared minus 2? Okay, I want you to see what is happening. We are given y is equal to 2x squared minus 2. Okay, that's 5.5. I want you to take note what we are given here. So on 4.5, now y is equal to 2 to the exponent, not 2 to the exponent, but 2x squared minus 2. Previously, our f of x was written as negative 2x squared plus 2. What actually happened? You can check that we simply multiplied this by negative 1, and also this by negative 1. And we know that the transformation of y is equal to minus f of x like this. It's a transformation which occurs when it is a reflection in the x-axis. So this is a reflection in the x-axis. So you're supposed to know your transformations. Guys, please revise this part. All right, so that was actually 2 marks for that question. 4.5 to, we have a total of question 4, 12 marks. All right, so question 4, I think it was direct. But if there are some questions, guys, that are giving us, so let me know so that we can work on those questions differently. Yeah, there are so many ways that you can use to make you understand. Let's see this part here. The sketch below shows the graph of f and g, the graph. So these are the 2 graphs, f and g. So f is given as 1 over x minus 1, which is a hyperbola. Then gx is given as ax plus q, which is a straight line. So this is a gx, and that's our f. So you know that from our hyperbola, this is our asymptote here, which is at x is equal to 0 and y is equal to minus 1. So that's why we see here at y is equal to minus 1, there's a line, that's your asymptote. All right. Point A is given as minus 1 minus 4 here. Point A on the straight line. And B, which is 3, 4, also on the straight line, which is also on G. The graphs, the 2 graphs, they intersect at C and D. That is the point of intersection, D in the x-axis and C at this point that we do not know. All right. The line BE is drawn. BE is drawn parallel to the y-axis. Okay, so this is actually parallel to the y-axis. We had that typical question. It was November 2016, but that one they made an error. Okay, so this one, they are parallel to the y-axis. So what does it mean? It actually means this will be at 90 degrees to the horizontal line that we are going to have here. It will be at 90 degrees, having the same value at x. So which means at this point E, x is equal to 3. All right. Anyways, we shall see that one later on if there is a need for us to show to use that one. All right. On 5.1, show that A is equal to 2 and Q is equivalent to -1. All right. That's A and Q. So A and Q, they are found on the straight line. So that's on the straight line. So this is 5.1. We are given that G of x is equivalent to AX plus Q. If we are to take from the straight line where we know that Y is equal to MX plus C, we can take and look that M is the gradient, which means A here is representing M, which is the gradient, where we know that the gradient is the change in Y over the change in X. So that's Y2 minus Y1 over X2 minus X1. So what can we do now to find the gradient? Remember, there's an advantage that we have because we are given 2 points which lie on the straight line, which is A and B. So you can just say X1, Y1, and this is X2, Y2, depending with the way that you are going to write your values. So that means we can obtain the value of A, since we said A is the gradient, which is M. So that's Y2 minus Y1, which is Y2, that's 4, minus Y1, which is minus 4. So that's a plus. Over X2 minus X1, X2 is 3, X1 is minus 1, so it's 3 minus minus 1, which is a plus again. Or we can just utilize our calculator at once. The calculator, 4 minus minus 4, everything over 3 minus minus 1, 3 minus minus 1. That is going to be 2. So our A, which is the gradient, is 2. So A is equal to 2. To find the Q, you simply have to substitute now into the equation, just like the way you find the equation of a straight line. y is equal to mx, where m is 2, which is the gradient, so it's 2x plus c. So to find the c, which is our q in this case, this c is represented by q. You are going to substitute any one of the points, either point A or point B. So in this case, I'm just going to use point B, the one that has got positive values. So x here is 3, y is 4. So y is equal to 4 when x is equal to 3. So we can calculate q here. 2 times 3, that is 6. If we transpose the 6 to this side, that will be a negative. So that's 4 minus 6, which is negative 2. So that's q is going to be equal to minus 2. So we've managed to show that. So that means we can even rewrite our gx here as gx is equal to a, that was 2. So it's 2x minus 2. Okay, so that means we know the value. We know the equation now. All right, now we are given, determine the values of x for which f of x is equal to gx. Which part do we have our f of x equal to gx? That is the point of intersection of the two graphs at C and D. So remembering that at the point of intersection, these two graphs, they are equal. Guys, please take note. I've been talking about this. Please understand this. At the point of intersection, the two graphs are equal. So that's f of x will be equal to gx. So you can actually solve this simultaneous equation because you have got f of x here, which is 1 over x minus 1 is equal to gx. You have got your gx here, which is now 2x minus 2. So it's an equation. You can solve this. This is same as over 1 over 1. So to remove fractions, multiply by the LCM, which is x, multiply by x, each and every term, multiply by x. So that's x and x will cancel. Minus 1 times x, that's minus x, is equal to x times 2x. That's 2x squared. X times minus 2, that's minus 2x. So we formulated a quadratic equation. So we can choose to leave these values on this side, which is 2x squared minus 2x. Then we can transpose x to this side. That's a plus x. We transpose 1 to that side. That's a minus 1. Then this will be equal to 0. All right. So we're going to have minus 1 here equal to 0. Remember the format of a quadratic equation. So collecting like terms, we've got 2x squared minus 2 plus 1x, that's minus x minus 1 is equal to 0. So that's a quadratic equation that you have where you can use any format or any formula, quadratic formula, factorization. So I'm just going to use factorization to solve here. So let's solve the equation, guys. We've got 2x squared minus x minus 1 is equal to 0. From your factorization, we know that you multiply the first term to the last term because here the coefficient of x squared is not 1. So you're forced to do the longer way. So we need factors of negative 2x, but if we add them, they must give us the middle term, which is negative 1x. So that's negative 2x and positive x. All right. So substituting into the middle term, these factors, we are going to have negative 2x plus x minus 1 is equal to 0. So you can divide into 2 so that we can factor out 2x, which is common. So 2x squared divided by 2x, that's x, minus 2x divided by 2x, that's minus 1. Already here we are remaining with x minus 1. So you factor out plus 1 so that it remains as that. So the brackets are the same. So you're going to take out one of the bracket, factor it out, x minus 1. Then here we've got 2x plus 1. Equate this one to 0. So that means from this part, x will be equal to 1 or 2x plus 1. So if you transpose this, will be minus 1. You divide by 2. So x will be minus 1 over 2. So these are the values of x at the point of intersection 1 and minus 2, minus 1 over 2. So which one is going to represent D? Which one is going to represent C? You can see that D is on the positive side here. So that's where we have our 1. And C is on the negative side. So that's where we have our half. So that is what you're going to do. But okay, these are they x values or okay, let's see the values of x. So the question was the values of x, which f of x is equal to. So x is equal to what? X is equal to 1 or minus half. So that's what you're going to have. So that was the question, guys, when they are equal. Now they are asking us, for which values of x is gx greater than or equal to f of x? So it means where gx is above f of x. So let's check from our graph. Where do we have gx above f of x? So this is our g here. From this side, we can see that our g is above. Here from this side, we are actually we do not know the value up to, it's actually infinite from there. So you can see that our g is above f up to point D here. When it reaches point D, it now goes down at point D. Our g is now below, okay? To at this point, it's above actually, okay? It's below, then this point, they're actually the same. We can just say it's above after the asymptote, no, below of the asymptote, there is actually below. Then at this point, they are all positive. They're all on the positive. Then here it's now going down, which is the negative. All right. So at this point C, that's where we need up to the asymptote where x is equal to 0 here. We can see that our C is going this way, which is on the positive. So we can take from minus, okay, that was minus half. So it's from minus half to this 0 here. All right, so that is the first interval, okay? Let me write it here so that I don't confuse you guys. So that was 5.3. So your x is going to be greater than minus half at this point. But remember, we are given that it's greater than or equal to, so I shall put it as equal to. But at the asymptote, it won't be equal to 0 there because that's an asymptote. So it's less than 0. Then we talked about that region that we said before, this idea at D, which is 1. After D, going this side, that's 2, 3, 4. Our G is on top. So we're talking about the values of x which are greater than 1. So x can also be greater than or equal to 1. So these are the solutions that we are going to have when gx is greater than f of x. Okay, determine the length of the line BE, and that's 3 marks. Okay, where do we have BE? Want to find the length of BE. All right. So far, we know the value of B, which is it's actually a straight line. At E here, we just know that the value of x at E is 3 because it's a vertical line, a parallel line. So it's a vertical line. So we can take advantage of F because E lies on F. So we can calculate the value of y at point E. Okay, so this is 5.4. So we need the value of y at E, where at this point E, x is equal to 3. So we're taking advantage of F because it lies on F. We are given the equation for F here as 1 over x minus 1. Okay, so we need 1 over x. So we are going to have y is equal to 1 over x. We say the value of x here is 3. So it's 1 over 3 minus 1. Okay, so 1 over 3 minus 1, that is the value of y at that point, which is 1 over 3 minus 1. That's negative 2 over 3. All right, negative 2 over 3. So for you now to find the distance that is taken, we are going to subtract the points because this is the value of y here. So the distance BE is just going to be the y value at point B minus the y value at point E. So that's the y value here at point B is 4. So it's 4 minus the y value at E, which is negative 2 over 3. So you can add from your calculator, but that's 4 and 2 over 3. So there are so many ways you can use the distance formula. As long as you've got the point E, because you'll be having that, you can use the distance formula, but that can be a lot. Okay, but as long as we have the answer, guys. On 5.5, we are now given, write down the equation of h, where hx is equal to, so this one, guys, is just a direct equation. Hx is equal to f of x plus 3. So you simply take your f of x, then you add 3. All right, where is our f of x? This is our f of x, which is 1 over x minus 1. Okay, so it's going to be 1 over x because we are given as f of x. So it's 1 over x minus 1, but we are supposed to add a 3. So the moment we add a 3, that's hx. So hx is going to be 1 over x. We can collect like terms, minus 1 plus 3. That's a 2. So this is going to be plus 2. Guys, as you can see, 1 mark. So to make 13 marks on this person. All right, so that was the question. Then we move on to question number 6. We are given on question 6. Let's try to remove some other things here. F of x is given as ax squared plus c. F passes through the point, the x-axis at d minus 5 and d minus 1, where d is an interval. Okay, guys, okay, it's fine. The question is, determine the value of d on 6.1, and that's 2 marks. Which concept can we use? That is the question. Whenever, guys, we are given a question, think of a concept. There must be a concept that you can use. Okay. We are given that this graph, it passes through the x-axis. So these are the values of the x-axis that we are given at, all right, something like this. We do not know, is this a positive function or not? But whether it's a positive or negative, I'm just going to explain what is happening here. This is what you're going to have. Let's say your function was this, like this. If you are given a x squared plus c, your function, here, these values, or they are supposed to be actually equal. They are equal. These are equal in terms of the numerical values, but multiplied by different signs. So this will be my minus 2, this will be 2. This will be 3, and this will be minus 3, this will be 3. And the turning point is your y-intercept for a function of this format. Okay, so you can take advantage because these values in the x that we see, the values of x, all right, d minus 5 and d minus 1, we are saying for each to be equal, because like I was saying, if this is -3, -3, this is 3. We can simply see that we are simply multiplying one solution by a negative to obtain another solution. If this is -2, the moment you multiply by -2, you get the other solution. So that was the tricky thing that you are supposed to have, to say that if I am having one solution as d minus 5, if I multiply that d minus 5 by a negative, it must give me the d minus 1. So I have an equation that I can solve for d. All right, so let's solve for d. Expand the brackets, negative times d, that's negative d, negative times 5, that's plus 5, is equal to d minus 1. So collect the terms with d to one side of the equation, that's minus d, which is minus 2d, is equal to transpose 5 to this side, that will be minus 5. So it's minus 1 minus 5, which is minus 6, divided by -2 by -2. So d is equal to 3. It can be so many ways that you can use to solve this one. Or you can use the average concept, that the average of these solutions should be equal to 0. All right. That is, if we add the values of x together, they must give us a 0. So that's the average part. That's, we could have solved this as d minus 5 plus d minus 1. The average of this must give us a 0. So if you cross multiply, this is same as 0 minus 1. So it's going to be d minus 5 plus d minus 1 is equal to 2 times 0. That's a 0. All right. So collect like terms, 1d plus 1d, that's 2d. Minus 5 minus 1, that's minus 6, is equal to 0. So 2d is equal to 6. Divided by 2 by 2, d is equal to 3, using the average concept. So there are so many ways. Okay. So we have the value of d, which is 3. The question is now, determine the values of a and c if it is also given that f of 1 is -9. Okay, let's start with the values of d that we are given. Remember, these are the solutions. So let's start by the solutions that we are given. So that's 6.2. When d is equal to 1, the first solution is going to be what? When d is equal to 3. So we are substituting here 3. That's 3 minus 5, which is -2. So the first solution is going to be -2. The second solution, which is the value of x, if we substitute d, which is 3, is going to be 3 minus 1, which is 2. All right, so like I said, that if one value is a negative, the other one will be a positive. So you can see that they are the same. So we know that from the solutions that we have, these ones, f of x can be given with this formula, a into x minus x1, which is the solutions, x minus x2. All right. So using this concept, we can have our f of x as a is a into x minus x1, that's x minus -2, which is x plus 2, into x minus 2, in this one. So you can see that we can expand this. That will be a into, it is a difference of two squares, guys. We can note this from our difference of two squares. We've got x and x, 2 and minus 2. So this was taken from x squared minus 4 from our difference of two squares. Or you can expand the brackets, x plus 2 into x minus 2. You expand x and x, that's x squared, x and 2, that's minus 2x, 2 and x, that's 2x, 2 and minus 2, that's minus 4. So as you can see, minus 2x and 2x gives us a 0 here. So it's x squared minus 4. So now we are left to find the value of a on this one. So what are we going to do to find a? There is a statement that we are given here that f of 1 gives us minus 9. That is when x is equal to 1, y is equal to minus 9. So we can substitute that y being minus 9, all right, y being minus 9 and x being 1, we are going to have a into 1 squared. So 1 squared is same as 1. So it's same as 1 minus 4. That's 1 minus 4. So minus 9 is equal to 1 minus 4. That's minus 3a. Divide by minus 3 both sides. By minus 3 both sides. So a is going to be equal to 3. So that was the value of a, which is 3. So the question is for us to find, determine the value of a and the value of c. All right, so you can see that from this format that we have a is equal to 3. Then, okay, let me write the format. It was ax squared plus c. I want you to see what is happening here. F of x was given as ax squared plus c. So a here is this value that is affecting our x, because remember, it said ax squared. So we can rewrite so that we can find our c. So our f of x is going to be a here, which is 3. So it's 3 into x squared minus 4. So we've got x squared minus 4. So f of x can be given as 3 times x squared, which is 3x squared. 3 times minus 4, that's minus 12. So if we can write in this form, we can see that our c here is equivalent to negative 12. So c is equal to minus 12. All right. So that was it, guys. That was it. That was it. I just hope we are together. Yeah, let's hope we are together. We are following the concept. If not, let me know, guys, on the comment section so that we can find ways of explaining differently these questions. On question 7, that was on finance, where we are given that Zek travels, Zek likes to travel. Okay, so we are given that Zek likes to travel. He saved 5,000 Rand as spending money for his vacation in Australia at the end of 2015. All right. So that's what we had. Zek looks at the exchange rate on the internet using the information in the table below. Calculate how many Australian dollars they can buy for 5,000 Rand. So this was the information: foreign currency, US dollar, which is 1 US dollar, 1 euro, 1 British pound, 1 Australian dollar, equivalent to the Rand. So these are the equivalent in rands, and equivalent of 1 unit of currency now. So this is the equivalent of 1 unit, that is $1 to this, one. So we are actually working with the conversion 1 to this, 1 to this. So that is the conversion which is taking place. All right. So we are given here that how many Australian, so we are working with the Australian dollars, which is here on Australian dollars. Okay, under the Australian dollars, we can see that the dollar is actually going for 9, it's going for 9,518,569, and like that. That is for a dollar. So what about 5,000 Rand in terms of that dollar? So you're just going to divide 5,000 Rand is going to be more on this side. So it's 5,000 over this amount. So you're going to have 5,000 over 9,518,569 times a dollar. All right, so that's the amount that you're going to have. 5,000 divided by 9,518,569. All right, that's something like 525.29 if you round off properly there. So that's $525.29, which is the Australian dollar. All right, on 7.2, we are now given that Zek plans to make another trip to Australia at the end of 2018. Okay, on 7.21, assume that the average annual rate of inflation in South Africa will be 6.1% over the next 3 years in 2018. What amount of money will be equivalent to 5,000 Rand now? All right. So remember, we are given that it's actually in inflation, and this amount of money is in Rand. So you can just take the 5,000 Rand that we have, because this is the money that is under inflation. All right, so inflation, that is a compound interest. Okay, if it is higher purchase, then that is simple interest. So this one is an inflation which is under compound interest formula, where we know that the amount is equivalent to P into 1 plus I to the exponent of N. So we need the accumulated amount after the inflation of depositing or of having 5,000 Rand, increasing at an interest of I here, which is 6.1%. So 6.1, if we divide by 100, that's 0.061. So it's going to be 0.061 to the exponent of N, which is the number of years in the next 3 years from 2015 to 2018. So that's the total amount that you're going to have. So 5,000 into 1 plus 0.0161, all right, to the exponent of 3. That will be the amount. Okay, so we are going to have 591, and you can check this 9 is going to round off 4 into 5. So it's going to be 5971, comma, it was 95. All right, so that is the amount that Zek is going to have after that inflation, after the heat inflation. The 7.22, Zek plans to invest equal amounts into savings account on 1 December 2016 and 1 December 2017 to have accumulated an amount of 5,980 by end of 1 December 2018. If this account earns an interest of interest at 9% per annum compounded annually, how much money should Zek deposit into the account on each occasion? All right. Okay. Let me remove this this question, guys. I have to explain. I don't know how am I going to explain it so that you understand me here. All right, this is what is happening with Zek, guys. He is planning to invest a certain amount of money. It's actually equal, which means the same value. Take note here. Invest equal amounts of money. Okay, we know that the amount, because this is compounded, so which means we're talking about a compound interest. We know that the amount is supposed to accumulate to P into 1 plus I to the exponent of N. All right. So this is an occasion that is going to happen in December 2018, which is the last one, from 1 December 2016. All right, so we've got December of 2016, December of 2017. So which means the first amount that is going to be deposited on 1 December, all right, on 1 December 2016 and on 1 December 2017. All right, let's start with the 2016 one. If deposited in 2016, 1 December, we are going to have the December of 2016, which is that is where we are having the final one. Okay, the December of 2016, the December of 2017. I mean, the December of 2017, the December of 2018, because it's actually in December. So from the December of 2016 to 2018, there are actually 2 years from these Decembers that we have. So the first amount of money that we do not know, okay, is going to accumulate. Remember, the total amount that is supposed to accumulate is this one. It has accumulated an amount of, so we have got 5,980 equal to the first deposit, which we do not know. So you can say, let P be equal to X, or you can just leave it as a P. If you want, you can just leave it as P. We do not know the initial amount. But we are given the interest rate for that amount, which is 9%. 9 over 100, guys, that's 0.09 to the exponent. Now, let's start. We said the first one for 2016, it is going to cover 2 years. So it's going to be to the exponent of 2. All right, whatever that we have from this amount, there is another investment, another amount that was deposited on 1 December 2017. So from 1 December 2017 to 1 December 2018, that's a 1 year. So this one is going to be, we add that one now, which is P again into the interest does not change. It's still 0.09, then to the exponent of 1. Guys, please understand me here. Please, guys, there are two investments with the same amount of money. That is why I am leaving this as P. But the first investment is going to mature in 2 years. The last investment is going to mature in 1 year. That's why we see this one. So the question is to calculate the money that was deposited on each occasion, which means we are supposed to calculate P. So that is what we are supposed to do. So what can we do to calculate P? Guys, we can just factor out P because P is common here. We are adding. So we can factor out P. We remain with 1 plus 0.09 to the exponent of 2 plus 1 plus 0.09 to the exponent of 1. So that's what you're going to have. So to have P, we can just divide this 5,980 divided by the whole of this bracket. Okay, let's just do it on our calculator. So we said we are going to divide 5,980 divided by the whole of the bracket. So the first one is 1 plus 0.09 to the exponent of 2 plus the other bracket, which is 1 plus 0.09 to the exponent of 1, which is just like that. So we are going to have 2624,994, which is just 0.99. So that is the amount that is going to have on each occasion. All right, so this was going to be 2624,99 Rand. So that was the money that he was depositing on each occasion. So that was finance having a total of 9 marks. 9 marks on question number 7. All right, let's check the other part of the question, which is question number 8. At a certain school, there are 64 boys in grade 10. Their sport preferences are indicated below. So these are 64 boys in grade 10. So they prefer 24 boys play soccer, rugby, 28, 10 boys play both, and 22 do not play. Represent this information on a Venn diagram. Okay, can we just try and have our Venn diagram? Maybe this side is gonna work since we have put our information here. So let me see, guys, if I'm going to win. All right, so this is 8 point. All right, okay, let's see the 8 point later on. All right, so you're gonna have a circle. All right, like this. Okay, guys, no. I need a circle like this. Okay, like this. Let's just increase a little bit. Fine. All right, then another circle here. Okay, this is too small. Oh, no. Okay, I see. We're supposed to remove one and work with this one. Is it gonna work? Is it gonna work? All right, guys, let me just do this. Let me just remove this. Is it gonna remove now? All right, so the question is it gonna remove or not? Okay, all right. I wonder why did I even use this concept? Okay. It's fine. Okay, it's now removing everything. No. I didn't want it to remove everything. So guys, please pardon me. Please just pardon me. Okay, let me remove this one. All right, exactly. Now let me put my circle here. All right, sorry. Thank you guys for the patience. All right, so you're gonna have something of this nature because there's an intersection. There are those who play both. So you've got 2 here, which is soccer and rugby on this one. So this is the total of the universal set. All right. So on 8.1, we are given that there are 64 boys, that is the total. And 24, they play soccer. So which means in soccer here, there are 24, all of them. In rugby, there are 28, all of them. All right. Then 10, they play both. So which means 10 is found here. 22, they do not play any of these. They do not play soccer, they do not play rugby, so they are found outside of the universal set. So it's an advantage here because we are given those who play soccer, they are 24. So we can find these ones who play soccer only. So it's going to be 24 minus 10, and 24 minus 10, that is 14. Here we've got 28 minus 10, and 28 minus 10, that is 18. All right, so we're going to have 18, guys, just like that. So this one was direct question. 8.12, calculate the probability that a grade 10 boy selected at random plays a soccer and rugby. Okay, so we need soccer and rugby. So soccer and rugby, that is the intersection of these, which is what? Which is 10 on the intersection. So this one is going to be 10 over the total number of boys, which is 64. So that's it. Probability required outcome over possible outcome. So 10 divided by 64, that's 5 over 32. So this will be 5 over 32. B, soccer or rugby, those who play soccer or rugby. So we mean the union of these two sets, combining these two. So we're going to add 14 plus 10 plus 18. All right, so that's 14 plus 10 plus 18 all over 64. All right, so if we add these numbers, what do we have here? 14 plus 10 plus 18, everything over 64. That is 21 over 32. All right, 21 over 32. So there can be actually so many ways of evaluating this or writing this. You can even write as fractions, guys. I don't know which one is best for you. You can even write as fractions. All right, on 8.13, we are given the events a grade 10? Are the events a grade 10 boy play? Okay. Are the events a grade 10 boy plays soccer at the school and a grade 10 boy plays rugby at a school mutually exclusive? Justify your answer. Are they mutually exclusive? No, guys, this is wrong because there is an intersection. We saw that there is an intersection between these two of 10 elements. Because under mutually exclusive, we know that the intersection of the two, that is soccer and rugby, if we are to have the intersection of these two, it must be equal to 0, but this one is not equal to 0. So they are not mutually exclusive. Okay, so they are not these ones. On 8.2, one morning, Samuel conducted a survey. So there's a guy called Samuel who is conducting a survey in an area to establish how many passengers, excluding the driver, travel in a car. The results are shown on the table below. Number of passengers, excluding the driver, okay, 0, that's 0 cars, 1, 11. Calculate the probability excluding the driver. Okay, calculate the probability that excluding the driver, there are more than 2 passengers in the car. Okay, there are more than 2 passengers. Okay, so we just need to use our table here. These are the number of passengers. So more than 2. Take note, it's more than, not equal to more than, which means we are referring to 3 and 4. These are the ones which are more than 2. So we are going to add these 2. That's 3 plus 4, which is 7. Then also you add the total, the number of cars, how many are they? The number of passengers in the cars, how many are they? So you're supposed to calculate the total. So the total, we add everything in this case, which is, all right, let's add. Guys, I'm just gonna add here. 7 plus 11 plus 6 plus 5 plus 1. Okay, so there are actually 30 cars which are there. All right, so you're having a total of 30 cars. All right, there are 30 cars. Okay, so let's check the question again, guys. I'm the one who is not. Okay. Calculate the probability that excluding the driver, there are more than 2 passengers in the car. Okay, so here this is what is going to happen, guys. Sorry for this. There are more than 2, so it means we are going to refer to the number of cars. Okay, more than 1, we've got 3. More than 2, we've got 3, which corresponds with 5 cars. 4, which corresponds with 1 car. So we're going to add these 2. 5 plus 1, that's 6. since we are using the number of cars here, we must also use the total in terms of the number of cars. So the probability is going to be 6 over the total of cars, which is 30. 6 over 30 from our calculator, that's 6 divided by 30, or just 6 over 30, which is 1 over 5. So this is going to be 1 over 5 or 0.2 as a decimal. I can even check there. All right. So that was the probability there. Okay, on 8.3, if you throw a dice at the same time, okay, the probability that a 6 will be shown in one of the dice is 10 over 36, and the probability that 6 will be shown on both the dice is 1 over 36. What is the probability that 6 will not show on either of the dice when you throw the dice twice? When you throw 2 dice at the same time. All right. Let's think. We know that it said that we are talking about a die in this case. So if there are 2 of them, we are going to obtain the other side as 10 over 36, the other side as 1 over 36. That is of showing a 6. Okay, we know that the probability of everything, the probability of obtaining a 6 plus the probability of not obtaining a 6 should give us a 1. So the question is, what is the probability that 6 will not show? So we need the probability of not obtaining a 6, which is the probability of not obtaining a 6 is 1 minus the probability of obtaining a 6. All right, remember there are 2 dice that we are talking about. So the probability of obtaining a 6, there are 2 that we are given. One side is 10 over 36, the other side is 1 over 36. So we are going to multiply the 2 outcomes, that's 10 over 36 times 1 over 36. So this is the probability of obtaining a 6 from the 2 dice. So we subtract that one from 1, we remain with the probability of not obtaining a 6, which is 6 complement. So that's not getting or not obtaining a 6. So that's you guys and your calculator here. All right. 1 minus, we need a fraction, 10 over 36 times 1 over 36. So this is what you're going to have, which is the, all right. Guys, what is happening? There are 2 sides. This is big. Okay, I'm the one who is making an error. These are 2 probabilities, guys. If we are to put on a diagram, is the first one plus the second one. So you're supposed to add. Hey, guys, sorry for this. I just hope someone saw this and was like, what is happening here? Are we not supposed to add? Okay, we are supposed to add those 2 outcomes, because if we are to represent on a tree diagram, that was going to be branch A plus branch B. Okay, maybe I can explain in another way. So that's 25 over 36. So we are obtaining 25 over 36 like that. All right, let me try and explain in another way. All right. So it's like this, guys. It's actually like this. We have got the probability of obtaining a 6, not obtaining a 6, the first one. The second one of not obtaining a 6, not obtaining and obtaining a 6. But this was going to take us a lot of time. Not obtaining a 6, obtaining a 6. Okay, so the first one, it's actually the first outcome and the second outcome of a 6. So not obtaining a 6 is this one that we have. So that is why we have to add these outcomes and subtract. The tree diagram, was it going to be useful? Okay, anyways, that was what we had. So I'll actually work with another method here. I'll actually come back with this question. So what I want you guys is to, work on this and see if you can obtain the 100 marks that was given there. If not, then let's revise as much questions from our past exam papers, revisions, textbooks, and also our videos at Maison African Motives. So like I said, I'm going to come back again with this question. So please, guys, make sure that you also remind me to work out this question with another way so that you can understand. Yes, I know there are so many ways and we can't finish these ways. Okay, so that's what we had, guys, for Maison African Motives, working on grade 10 mathematics. till we meet again.